All right, so our last section for chapter 7 is 7.6, and it's solving trig. We're mostly going to focus on equations. We might do a few inequalities, we'll see, but solving them analytically. So analytically means algebra, okay, not just graphing it and finding an intercept. If it's going to be solvable with algebra, it has to work out nice. You can't just make up any trig problem and have it work. So all of these are going to have a trick that makes them work out nice. So all the techniques that you know for solving equations, you can use with trig identities. Okay. Factoring, that's a trick we can use. And the kind of factoring you want to remember is, if you could factor something like this, if you could factor x squared plus 3x plus 4, then you could factor sine squared plus 3 sine plus 4. Factoring what's above and what's below, it's exactly the same steps. The only difference, literally, is that instead of an x, you have the word sine. That's the only difference. Okay, so we'll go over factoring. Writing everything in terms of one trig function. So if you have a problem that has multiple trig functions in it, like this one, this is no good. No good. No good because you've got cosine and you've got sine in the same problem. We have to fix that. And I'll explain how when we do it. Another approach we use to solving trig equations is quadratic formula. Exactly the same quadratic formula you know. So quadratic formula, you use that when you can't factor. Or some people use it even when they can. But usually you use it when you can't. So if I had something like this, that's not factorable. I can't find two numbers that multiply to give me 2 and add to give me 5. At least not nice integers. Okay, no fractions. Can't do it. So we would use quadratic formula. And when you use quadratic formula, what would you be solving for? You're solving for whatever is written right there. So when this problem is done, you would get x equals. Well, let's change it. Let's say you had sine squared plus 5 sine plus 2. That's basically exactly the same problem, and every single step in this problem is going to be the same as every step in this problem, except the very last step. When you are done the one on the right, you didn't find x. What you solved for was sine x. You're always solving for whatever is right next to the number in the middle. If it's a quadratic like that, it's usually x. On the one on the right, it would be sine x equals. So then in a problem like the one on the right, you'd have one more step. You'd have to get rid of sine at the end. And how do we get rid of sine? You use inverse sine. But other than that, every single step in the quadratic formula would be the same. In the problem on the right, you could put a 1 in front, just like you could put a 1 here. A is 1, B is 5, C is 2. You do it just like you would do the normal quadratic, except you do that at the very end. Say sine x equals, not x equals. Okay, but we'll practice that too. Right, so those are the general things we're going to try. Okay, let's try an example. Okay, the first one, the problem with this, the reason it's no good, you've got two different trig functions. That's like writing something like this. 2y squared plus x plus 1 equals 0. You can't really do that if you've got two different variables. It's not good. Okay. We've got to have all the same variable. So I put on the board an identity from last week. Does anyone remember what group of identities that was in? There was a name for it. Starts with a P, it's one of three. That's a Pythagorean identity. So what I want to do is use that to change this. I want to rewrite cosine squared. So the way I'm going to do it is I'm going to use this identity. And what could I subtract from each side that would get this by itself? Subtract sine squared.
Please excuse the interruption.
All right, so I'm going to subtract it on the left. It's gone. Subtract it on the right. Now, what's on the left by itself? Cosine squared. And what does it equal?
1 minus sine squared.
1 minus sine squared. We just came up with a new formula for cosine squared. And what that formula does is it changes cosine into sine. And that's what we have to do. Question? Okay. So,
yeah. Can you do it again?
so it just subtracted sine squared from each side. I'm assuming that this identity is good. Sine squared plus cosine squared
How
equals
did you
1.
get that, though?
That's from last week. That's a Pythagorean identity.
Should be in your notes.
It's one of three in a list in your notes.
Yeah, alright.
So you got to go off that.
I was good with this.
And then from there, we just moved one thing to the other side. Yeah?
So would that cosine formula go where cosine used to be?
Yep. So what we're going to do is, instead of writing cosine squared, I'm going to write 1 minus sine squared in place of it. Okay. And once I do that, the whole problem is going to have sines in it. Okay? So let's do it. So we've got 2. Okay. Don't put cosine squared. You're going to put what cosine squared equals. 1 minus sine squared. Now, why did I leave it in parentheses?
Because that's the 2 is being multiplied by
Yes. Because it's 2 times whatever's in that circle. I just changed what's in the circle. That 2, eventually, when in the next step, you have to distribute it. The rest of it is going to stay exactly the same. So keep sine the same, keep the 1 the same, keep the 0 the same. Now the whole problem is with one trig function, just sine. That's better. We got rid of cosine. So now we need to distribute it out. What's 2 times 1?
2,
2, but then I have a plus 1 at the end. So what's 2 plus 1?
3.
So I'm going to get a plus 3. And usually when we write a quadratic, we put the number at the very end. So I did 2 times 1 is 2. Plus I've got 1 more at the end is plus 3. Now I've got 2 times negative sine squared x. It's not really much you can do with that. It's just negative 2 sine squared x. The middle, it stays exactly the same. Okay. Any questions on distributing out the 2? All right, so now we have to decide if this is the kind of problem we can factor, or if it's the kind of problem we can use quadratic formula. Okay. Let's see if we can factor. I think the first one I give you is factorable. So I'm going to write this a little differently, the way you would see it in algebra. Okay? It would be negative 2x squared plus x plus 3 equals 0. Okay? Just watch this step. When you're going to factor it, you always like this number to be what? What kind of number?
Positive.
You always want it to be positive if you were going to try to factor this. So in Algebra 1, you would write it like this. What did I just do to make...
Change all the signs.
I just changed all the signs. Okay? You can do that. It's like just multiplying everything by negative 1. Well, if you can do it in algebra, you can do it in trig. It's the same thing. I'm just going to change the sign of everything. Because that's how we're used to factoring. We always like that positive, not negative. Can you do it if it's negative? Yep. But that's not how you were taught to do it. Positive 2 minus sine minus 3 equals 0. Now, what I'm going to do to factor that is I'm going to factor it pretending like we just had x's, okay, just to kind of avoid sign for now. So I want you to just try to factor this. If you can factor that, it's the same as what's above it. 2, negative 1, 3. So start with your parentheses. What would be your first term in each set of parentheses?
One would be 2x.
One would be a 2x, and the other one? Just a regular x. Now, if we were factoring it with sign, it would be a 2 sign and a sign. I'm going to do it with x's first. And then when we're done, we can just change x to sign. If you don't want to do this step, changing the signs to x's, you don't need to. I'm just trying to show you how all you're doing is factoring an algebra problem. Don't get confused by the word sign. Now, what about my symbols inside?
Positive, negative.
I need a positive and a negative. It does matter which one goes where. I just put them in the order that I heard them. Now I need two numbers that multiply to give me 3 and subtract to give me 2. I'm sorry. Actually, just think of two numbers that multiply to give you 3. Start with that.
3 and 1.
3 and 1. Let's try 3 and 1. Let's check it. 2x times negative 1 is
2x. I mean negative 2x.
negative 2x. And what's 3 times x?
3x.
What's negative 2x plus 3x?
1 just x.
1x. That's exactly what you want in the middle. 1x. So we factored it correct. Okay. So in order to get from this to this, what did I do? I just changed what to what? Change sign to
X.
and the only reason I did that is to make it look visually simpler for you. Okay? But remember, it wasn't an x, it was really sine. Okay? It wasn't an x, it was really sine. Okay? So now that we factored it, making it look simpler, let's change x back to what it should be. And then maybe in the next problem, we won't have to do this step. We'll just factor it right away with the trig, instead of kind of pretending like it's algebra and then changing it back. So it's 2 sine x plus 3, sine x minus 1. That's how it really factors. Okay? But if this step helps
It
you,
looks the same.
it is. It's basically the same thing. You're just changing these two things. The factoring is exactly the same. Now, what do you do with each set of parentheses?
You set it to
Set them equal to 0. Now we've got a problem just like you had in the homework last night. We're going to get x by itself. Okay. I want to get this by itself. So how would I move the 3 to the other side? Subtract it. And how would I move the 2 to the other side? Divide it. So I minus the 3 divided by 2. Okay. Now I got to get rid of sign. How would I get rid of sign? Inverse. So the answer is the inverse sign of negative 3 over 2. Let's type that in and see what we get. Okay, I'm going to do it in degrees. Inverse sign. So second, sign. Negative 3 divided by 2. Get an error. What's negative 3 over 2 as a decimal?
negative 1.5.
It's negative 1.5. How high and low does that graph go?
1 and 1.
It only goes negative 1 to 1. Negative 1.5 is down here. If you're trying to answer the question that I just typed into the calculator, you're asking where does that dotted line cross that graph? It doesn't. So from this part, there's no solution. Doesn't mean there's no solution to the whole thing. We have one other problem. How would I get sine x by itself here?
Add one.
Add 1. And my last step?
Take the inverse.
Take the inverse sine. Now, does the graph ever hit 1?
Yeah.
Yes. In fact, I think I answered that in the homework. Here's your graph. It hits 1 right there. That's the quarter point. What's the x value a quarter of the way through the period? Pi over 2. And that's the answer. Okay, it takes a little bit of getting used to. It's not the easiest thing to do. Okay? But once you try a couple of them, all the problems that factor turn out like this every time. That's what usually happens. It's not always a no solution. Sometimes both parts work, and you get 2 answers. In this problem, just 1 answer. Okay. Okay. Any questions on that one? Okay, if you're looking in the book, I think I changed example 1 in the book a little bit, so the problem is it's a little different if you're following along in the book. We're okay here. All right, let's try another one. Okay. What's not on the right side in this problem that we had in the last one? 0. So that's always the first step. Get it equal to 0. Okay. So how would I move the 1 to the other side? Subtract it. How would I move the cosine to the other side? Subtract it. If you do that, what's on the right side now? 0. You have 2 sine squared. You have minus cosine, because it's on the other side, and minus 1. Now this problem is exactly like the one you just did. You have everything on one side. Okay. So let's go through all the same steps again. What's the first thing I would have to do here?
Change cosine to 1 minus sine.
Change what? We want to change something.
Cosine.
Cosine is okay. In the last problem, we changed the thing that was squared. So in this problem, do the same thing. Change the thing that's squared. So, what was the Pythagorean identity? It says what? Just the original.
Sine squared plus sine squared plus cosine squared plus 1.
Yep. So use that to replace that. What is sine squared equal to?
Negative cosine plus. Wait, no. 1 minus cosine. Yeah.
Yep. Subtract this. Subtract cosine on this side. And you get sine squared is 1 minus cosine squared. So start with that. What do I do with the rest of it? Just copy it down. Keep it the same. Now what do I do with this 2?
Times by 1 and then minus 3. I mean minus 1.
So 2 times 1 is 2. 2 take away 1? 1. If you don't want to do that all in one step, you don't have to, but it's easier so you don't have to write it twice. 2 times 1 minus 1. 2 times negative cosine squared is negative 2 times cosine squared. You can't do anything with that. And then what about the middle?
Just copy it.
Just copy it down. Okay. Now, I want to see if we can factor this one the way we, just going right to the trig part. So if we're going to factor it, we would rather that this number be what? Positive. So how can I make it positive?
Opposite everything else.
Yeah, change the sign of everything. You don't always have to do that. Sometimes this number will come out positive and then you're good. It's just in the last two problems it hasn't. So let's make it 2 cosine squared. What would come next?
Plus cosine.
Plus cosine
Minus 1.
minus 1. Right. Does anybody want me to try to just do it with looking like this first? Or are we okay to just try to jump right to the...
Okay to just
Sure.
jump into it.
Ready to jump into it? All right. So the first two terms, those are the easy ones. What are the two things I would have to put so when I multiply them together, I get 2 cosine squared?
2 cosine and cosine.
Now we need a 2 cosine and a cosine. That's like putting a 2x and an x. Okay. Now I have positive middle, negative constant. So what do my signs have to be? Plus and minus. And two numbers that multiply to give me 1, you don't have any option here. 1 and 1. Let's just check and see if it works. If it doesn't, the only thing we can do is switch the signs. So we get 2 cosine times negative 1. That's a negative 2 cosine. 1 times cosine, that's a positive 1 cosine. What's negative 2 plus 1? I got negative 1. I wanted a positive 1 cosine.
So you have to switch the sign.
So we have to switch the signs. Now we get 2 times 1. That's a positive 2. Negative 1 times cosine. That's a negative 1. 2 take away 1. There's my 1. So now we factored it. Okay. What do I do with each of those? Set them each equal to 0. Let's see. So what would I have to do to move the 1 and the 2 to the other side?
Minus the 1 and divide the 2.
So do what with the minus 1?
Oh, sorry, add the 1 and,
Add the 1
and divide the 2.
and divide by 2. So add the 1, divide by 2. Okay, any question on that stuff? All right, so now what do I do on each side? Do the inverse cosine. So inverse, let me get rid of that. Inverse cosine of a half, I get a nice answer, 60 degrees. Now, I reminded you, we're going to think of that chart. Cosine is equal to a positive, 1/2 is a positive in 2 spots. I just got that one. Where else is cosine equal to a positive? 4. If you don't remember how to find the answers in the quadrants, this is 180 minus your angle. If you're looking in quadrant 3, it's 180 plus your angle. We're not using either one of those in this problem yet. This is 360 minus your angle. What's your angle? 60. What's 360 minus 60? 300. And if you're not sure, you can easily check your answer. Take the cosine of 300, plug it in right here. Take the cosine of 300 and see, do you get a half? Let's try it. Cosine of 300. It works, 0.5. Let's check the other answer. Plug in 60. Cosine 60, does that come out to a half? They both do, they both work. Okay, any questions on those two? Okay. And we do the same thing on this one, except there's not going to be multiple answers. Subtract the 1 to the other side. How do I get rid of cosine again? Inverse. And now just type that in on your calculator. Inverse cosine of -1. Inverse cosine, -1. 180. Now, is 180 in a quadrant? No, it's not in a quadrant. So you don't have to worry about any of this stuff. It landed right on an axis. If it lands on an axis, you're done. If it lands in a quadrant, then you have to do one of these three things. Okay. So it definitely is a lot of stuff to remember to solve, but this problem is as bad as it can get. It really doesn't get any worse than that. So if you can write that down as an example and you can follow it, then you're good. But we'll practice a couple more and see how we do. Okay. Any questions on those answers? Now, what if they wanted the answers in radians? What would you do with each one of these? No, multiply is right. Yeah. If they wanted the answers in radians, we could change those to radians. Either do it by hand or figure out how to use your graphing calculator to do it for you. It can. I would just do it by hand. If they ask me. Okay, I'm not going to ask you to do that here. All right, so this, just read this. You don't have to write this down unless you could write this if you wanted. There's this idea, remember, that there's infinite solutions. Remember with the trig equation, it's not just one answer. That answer is going to repeat every cycle. We're not doing that in this section. I want you to remember that that happens, but you do not have to write down plus the period times n. We did that before. At this point, I already know whether you know how to do that or not, so we're not doing that again here. We're doing exactly what we did on the last two questions. Okay, so don't even write this. Okay, so we are not finding complete solutions. Any questions on that? So what does that mean? You don't need to put on the answer? You do not put the period plus period times n. We're not doing that in this section. I'm only asking you to find the answers from 0 to 2 pi because that's already hard enough. Okay. Do we have everything in the same trig function? No. What trig functions have we been using in the last couple problems? We've had all sines and cosines, so that's a hint. Does anybody remember how you can write tangent? It's sine over cosine. So start with that. Okay? Write tangent as sine over cosine, because that's how we've been doing it. So sine divided by cosine. Keep the other side the same. So at least we're one step closer to the kind of problems we had before. We got rid of tangent. Now, how can I move cosine to the other side so I don't have a fraction on the left? Yeah, multiply by cosine. It's just like if you had this. And I said, how would you move the 5 to the other side? Multiply by 5. Multiply by 5. Now you don't have a fraction anymore. Let's do the same thing here. Multiply by cosine. And multiply by cosine. What's on the left-hand side now? Mike? It's on the left.
Sine x, sine x.
Well, all that's gone.
Oh, just sine x.
Sine x. Yep. So sine x. And Casey, what's on the right?
3 cosine squared x.
Yep. Now you've got a problem where you've got sine on the left, you've got cosine squared on the right. It's exactly what you had right here. Cosine on one side, something squared on the other side. Right. So, from here, we're going to move everything to one side. All right. What side did people put stuff on? Did they get the 0 on the right or on the left? And if you didn't do it, pick a word.
I moved the sign to the right.
You move the sign to the right, so you put 0 on the left.
Yeah.
That's fine. You can do it that way. I'm going to put the 0 on the right. Okay? And I'm going to show you why, because it's going to avoid something we've had to do in every problem. If I do it that way, you won't have to do this. So put it on the left. And you might be like, well, wait a minute. Now you just created negative cosine. I thought you didn't want negative in front of the squared. Watch what happens. Yeah, you need to go. So you have negative 3 cosine squared. And now, what does cosine squared turn into? One minus sine squared. Watch what happens when you distribute to the number in front of the square term. What's negative 3 times 1? Negative 3. And actually, you know what I'm going to do? I'm going to put it over here. What's negative 3 times negative sine squared?
Positive 40 cosine squared.
That's why I put everything on that side. Is it a big deal if you put it on the other side? No. You're just going to have to change the sign of everything in the next step. I just avoided that in this problem. Okay. That's why they pay me. Okay. So, any questions on getting it to that step? Now, this is going to be the first one that if you try to factor this, like if you wrote it this way, that doesn't factor. You can't factor it nicely. So what's the other method we have if it doesn't factor?
Quadratic formula.
Quadratic formula.
Or easy.
In the equation up above, what's A?
3.
3? B?
1.
And C?
Negative 3.
So do the quadratic formula just like you would always do it. There's no difference. Do exactly the same thing. So negative B. Plus or minus, what comes next?
4. Oh, 3.
B squared minus 1.
Isn't it negative? No.
B squared minus
4AC.
4AC. So 4, 3,
Times negative 3.
negative 3. So that's
Over
4AC
1
over
and 2A. Or 2A.
2A. What's going to happen here? Minus a minus. So let's just make that positive right now. 4 times 3
12.
times another 3
36.
plus 1,
37.
37. Now, if you were doing an algebra problem, that's it, you're done. What did we just solve for?
X.
Not x.
Sine.
Sine x. You always solve for what's right in the middle. In an algebra problem, it would be just an x. In this problem, it's that. Okay, so any question up to that step? Okay, what I want to do to make make this easier is let's find the decimals. That's going to be a lot easier. How many answers does this represent right here? 2, plus and minus. So just type it in. -1 plus the square root of 37. And then divide by 6. So one answer is 0.847. Just round it to 3. And now do the same thing except do -1 minus the square root of 37. So -1 minus the square root of 37. And what do I divide by? 6. Other one is -1.18. Okay, what do I do on both sides to get x by itself? So we've got that. Well, setting it equal to 0, that was actually back up here. So we did that. We got to get rid of sign.
Inverse sign.
Inverse sign. The steps aren't going to change. It's going to be the same steps for every single problem. Inverse something at the very end. So we need to type that in. And on the other side, what do I do? Inverse sign again. Now look at that right-hand side. What's the lowest that sign goes? That's the highest. The lowest it goes is -1. It's not going to hit -1.18. If you don't recognize that, just type it in. You're going to get an error. It's not a big deal if you forget. What's the highest sign goes? 1. So 0.8 is definitely under 1. We're going to get an answer. What is it? 57.89. Is that in a quadrant or on an axis?
Quadrant?
Definitely in a quadrant.
Okay, how do you know it's in a quadrant?
If it's not a 0, 90, 180, or 270, it's in a quadrant.
Okay.
So we got an answer in quadrant 1. That's 0, 90, 180, 270. Where else is sine equal to a positive number? Between 90 and 180. What's the formula if you're between 90 and 180 to get the other answer?
180 minus whatever your
180 minus whatever your
angle is.
angle is. So 180 minus 57.89. 122.11. And that's it. Those are our two answers. Could I check? Sure. Plug in 122 and take the sign of it and see if you get 0.847. You should. If you do, you did it right. If you didn't, check your arithmetic. Okay. Any question on that one? All right. Let's try something a little different. That's kind of the same thing. It's got something squared on one side, something not squared on the other. There's nothing new to learn from that one. Let's do... It doesn't matter. All right, let's try that one. So it says 3 tangent to the 4th equals 1 plus secant squared. Okay, so we want to get everything in with one trig function. We've always replaced the one. Which one is the one we've always replaced? The squared one. In every problem, we've taken the thing that has been squared, and that's always what we replace. Okay, always replace the squared one. So that's probably important to write down.
1 plus 2.
Right. That's an identity. 1 plus tangent squared equals secant squared. Remember, there were 3 Pythagorean ones. We've been using sine squared plus cosine squared. That's a different one. So we get 3. Left-hand side stays the same. Secant squared turns into 1 plus tangent squared. So all I did was change what I circled using that identity. What can I do on the right-hand side? Yeah, you can simplify. Yeah, what's 1 plus 1? 2. And then how would we bring the 2 to the other side? Let's subtract it. Let's do that at the same time. Leave tangent to the 4th where it is. You get 2 on the right, but I'm going to bring it over to the left. And I'm going to bring tangent squared to the left. Okay, how would I bring that over as well? Subtract. Okay. Any questions up to that step? Okay, from here, this one is going to be factorable. I know we've kind of been getting used to doing it without the algebra, but let me write it like this. Let's factor that first. And then if you can factor that, that's exactly the same as what's up above. Okay, what would have to be my first term in each set of parentheses, so when I multiply them together, I get 3x to the 4th. Perfect. 3x squared and 1x squared. So really, it's 3 sine squared and sine squared. That's what it really is. Now, 2 numbers that multiply to give me 2. 2 and 1. And my sines would have to be plus, minus. Let's try it. 3x squared times negative 1. 2 times x squared is negative 3 plus 2, negative 1.
Oh, yeah.
Yeah. So we factored it correctly. So what was x really though? We just did that to make it look easier. X is really tan. So write what you have right here, but change your x's back to tans. Again, this step is not necessary. If you don't want to do it because you can see the trig in your head, that's all right. Just do it that way. So 3 tan squared plus 2 tan squared minus 1. What do we do with each one of those? Set them equal to 0. 3 tan squared plus 2 equals 0. Tan squared minus 1 equals 0. How do I move the 2 and then the 3 over? Subtract.
The 2 and divide the 3.
Subtract the 2. Minus the 2. Divide by 3. Now, I have tan squared. I want tan. So how do I get rid of the square? Take the square root. Square root, square, gone. And now, how would you get rid of the tangent?
The inverse of negative.
The inverse tangent. But look at what you have before you even do that. Look at the right-hand side. What's going on the right-hand side? It's the square root of a negative number. What does that mean? You can't do that. That's imaginary. So you can do inverse tangent if you want, but you're wasting time. Square root of a negative is an imaginary number. There's no solution from this whole part. So you can stop. Could you have known beforehand that there was no solution? No. You got to do it. There's no way to know beforehand. Okay, so I'm done with that part. Let's look at the right part. Okay. What do I have to do on this. Add the 1. Now what do I do? Now I can take a square root, and it's okay this time. What is the square root of 1? Yes, the square root of 1 is 1 or negative 1. Sometimes people forget the other answer. And now what am I going to do on both parts?
Inverse tangent.
Take the inverse tangent. Okay, so let's do inverse tangent of 1. So second inverse tangent of 1, 45. Or do the inverse tangent of negative 1. Second inverse tangent, negative 1, negative 45. If you look in the book, they had, they did it in radians. So they had pi over 4 and negative pi over 4. Okay. Any questions why we didn't have to finish that left-hand side? Or why I got 2 answers on the right? All right. Let's pick one more. Let's do this one. Sine 2x equals x. Do I technically have all the same trig function there? What do you think, Mina?
No.
No?
I don't think.
We have the same trig function. Do we have the same thing inside the function? No. Every problem has always had the same thing inside. X, X. X, X. Okay, I can go back to all of them. X, X. Okay. X and X. We've never had one where it's been like this. 2x and x. That's no good. It's got to be an x. So yesterday we learned something that showed us how to get rid of the 2. Does anyone remember the identity for sine 2x? It's under the section that says double angle identities. Yep.
It's 2 sine times cosine.
It's 2 sine cosine. Exactly. Okay. People, I want to make sure that we're okay with that stuff. People remember that identity?
Wait, when did we learn?
It's yesterday. It's under double angle identities. You got it? Okay. Okay, so 2 sine cosine. And if you get that, this one's actually going to be the easiest one we've done so far. I promise. It's the easiest one. Now, what number do we always want to get on one side? 0. So the easiest thing would be to just move this to the other side. How would you move it? Subtract it. 2 sine cosine minus sine equals 0. One of the reasons this one is going to be so easy is there's no constant. There's no number that's hanging out there like this. Okay. Or like we had here. Everything is a trig function. What does the 2 things I just underlined, what do they both have in common? Sine. So what we're going to do is we're going to factor it right now. No quadratic formula, no complicated factoring, simple factoring. If you factor a sine out of the first part, what are you left with?
Oh, 2.
Yep, the 2 and
Cosine.
cosine. If you factor a sine out of the second part, what are you left with? A negative 1. And now, what do we do with each of those? Set them equal to 0, and from here it's just like what we've been doing. Either the first parenthesis equals 0, or the second one. Okay. The first one is good because there's no numbers we even have to move. What can we do on both sides right away? Take the inverse sign. 0. Now think of, don't even use a calculator, just keep it simple. Where does the graph hit 0? 0. And what about right here? That's halfway through the cycle. 2 pi would be the end of the cycle, which is a repeat of 0. So we don't need this one. We need this one. Pi. If you want it in degrees, I can do it that way too. 0, 180. What if you didn't know that? You could use your calculator. Okay, so we get 0 and 180, or 0 and pi. Just showing you both. And the last one? How would I get cosine x by itself? Add 1, divide by 2. And my last step would be use the inverse. It's always the last step, inverse cosine. Inverse cosine of a half, 60 degrees. We did this, I think this was one of the first ones we did. Does anyone remember the other answer that we got? It was 300. It has to be in quadrant 4, so it was 360 minus 60. If you want those in radians, I can do it real quick. That one would be pi over 3 and 5 pi over 3. Don't mix radians and degrees in your answers. I don't care how you do it, but do all the answers in radians or do them all in degrees. Okay, so homework, it's page 423. On 1 through 9, they kind of guide you through the problem. We had to do all the factoring by hand. They do some of the factoring for you. Okay? On 13, 14, 16, and 19, you're on your own. You have to do everything like we did in class. Okay, but the first few are a little easier.